Okay, so we're going to have a look at the introductory calculations using solutions at GCSE chemistry. Now this is the sort of the video, I suppose, that you would watch before you start actually doing what we call titration calculations. So if we're just really going to manipulate our way around these various formulae, and if we look at the formula that we have here, we've got one that we had from year 11, which is our mass equals moles times RFM. Moles, small n, I'll use sort of for shorthand when I'm doing those on the board, so just be aware of that. We've got our masses in grams. We have our over here now, when we get into solutions, we have moles equals concentration, which is in the units of moles per decimeter cubed, which is a litre. Okay, so just remind yourself, if you don't remember, a decimeter cubed is equal to 1000 cubic centimeters. Sometimes I write cubic centimeters as cc. Okay, so just if I do write that, just so you know what I'm talking about. And also moles per decimeter cubed is often written as capital M. So when I talk about capital M, or even you read it in textbooks, websites, you're talking about moles per decimeter cubed. And the volume for this is in decimeters cubed in order for this equation to operate as you would expect. So you frequently have to remember that the question will give it to you in centimeters cubed, so you frequently have to convert it across from decimeters into centimeters cubed. And in order to go decimeters cubed into centimeters cubed, hopefully you'll be able to work that out anyway. Okay, centimeters cubed back into decimeters cubed is what it normally is. You have to divide the centimeters cubed by 1000 to do that. And the final equation that we'll manipulate our way around here today is concentration, this time in grams, which is just basically the mass of solid. That's in a decimeter cubed, or per decimeter cubed. When I write to the -3, that means per decimeter cubed. Okay, just like I have up here. And that is equal to the concentration in moles per decimeter cubed multiplied by the RFM. So we have three equations here, they're all interlinked, and we need to be able to work our way through them. Hopefully you can see the sort of the commonality, if you like, between them. So here I can work between those two equations by using moles. Okay, these two here are linked by concentration in moles per decimeter cubed, and over here we have RFM, although that's not probably going to be particularly important to us. So those are the formulas, guys. Maybe a good idea, because I'm not going to keep those on the board for very long, maybe a good idea to take a copy of those down, although you should probably have them copied down from class anyway. Right, so we'll do a few, just to give you sort of an idea of what's going on here and how we sort of manipulate between these three formulas. So let's take a nice simple question. I'll try and keep these on the board if I can. Hopefully we'll have enough room to do so. Okay, so if we look, see if you can see where we are here. Okay, so we'll do a few of these questions. We're not going to do them all, because if we did it would take us a little bit too long. Okay, so let's see. Try and get that onto the screen. Right, so what we're asked here is to calculate the concentration of the following in both moles per decimeter cube and in grams per decimeter cube both. So we've got 20 grams of calcium carbonate in 100 cubic centimeters of water. Okay, calcium carbonate doesn't actually dissolve, but just for the purpose of this question, it gives us a nice simple approach to doing this. Right, okay, so what do we need? I'll zoom back out here again just to bit more space. Now that you've seen the question. Right, well, we've got 20 grams, okay, of calcium carbonate, and it's in 100 grams of water. And I've got to get the concentration in moles per decimeter cube and in grams per decimeter cube. So the first thing I need to do to get concentration here is I need moles and I need volume. Well, I've got volume because it gives me it in 100 cubic centimeters. I need to remember to convert that into decimeters cubed, so I'll just do that very quickly. It's a good skill to be able to do that off the top of your head, guys. Convert that just dividing by 1000. Right. Then from there, what we're doing is we've got to get number of moles of this, and we can get moles by taking mass dividing by RFM. Well, the mass is 20. The RFM of this, if I add my 40, my 12, and my 48 for my 3 oxygens is 100. Okay, so that comes out at 0.2 is the number of moles. Concentration equals number of moles divided by volume. Volume is 0.1. Okay, so therefore I have a concentration in this instance of 2, and the units will be moles dm to the minus 3 moles per decimeter cubed, that, or capital M. And then I've been asked also to turn that into grams per decimeter cubed. So I've got my moles per decimeter cubed here, I've just worked it out. Okay, and then I've got the RFM. Okay, I've already worked that out over here as being 100. So it's simply 2 times the RFM, which is 100. So the concentration in grams per decimeter cubed is equal to 200 grams per dm cubed. Okay, hopefully pretty straightforward. We'll do another one and that'll kind of hopefully get the concept across as to what we're doing. Right, so we'll take one down at the bottom here, which is F. If you can see it, you can have a look at it there. So in fact, no, we'll take E, because E is in kilograms, so it just introduces another little thing that we need to be careful of. And we've got 2.79 kilograms, and we've got iron 2 dichromate, and that's in 5,000 cubic centimeters. So as soon as I look at this, the first kind of things that I'm just making myself aware of here is, firstly, my mass is in kilograms, and secondly, my volume is, this time it is in centimeters cubed. Okay, quite a lot of it, so I've got to again divide that to put it into decimeters cubed. Okay, right, and the next thing I need to do is work out the formula of iron 2 dichromate, because if I can't do that, I simply cannot do the question. Well, iron is a +2 ion, and dichromates have that formula, Cr2O7, but they are also a -2, so the formula of iron 2 dichromate is simply FeCr2O7. So we've got 56 plus my chromiums, 2 of them, sorry, 2 of them at 52 times 2 plus I've got 7 16s. So the RFM of this, as you expect, is quite large, so it's 272. Okay, so the moles of that, I've got to get moles per decimeter cubed, so I need to get moles, so I can get moles over here by taking my 2.79 kilograms, which I've got to convert into grams, so it's 2,790 grams, okay, divided by 272, okay, so 279 gives me 10.25 moles, okay. Now, so I've got moles and I've got volume. Volume is 5,000 cubic centimeters, but I need to convert that into decimeters, which is 5 decimeters cubed. Okay, so I divide my moles by my volume, 2.05 moles per decimeter cubed, and then finally I've been asked to convert it into grams per decimeter cubed. And the grams per decimeter cubed is simply, again, we go down to here, grams per decimeter cubed is concentration multiplied by the RFM. The RFM we've already worked out over here is 272. Okay, so therefore that comes out at 558 grams per decimeter cubed is the concentration there. Okay, so hopefully that allows you to work around converting masses into concentration in both moles per decimeter cubed and grams per decimeter cubed. We'll do another wee video also on how to take a concentration and a volume and turn that back into moles. So that'll follow this one. Okay, so if you just check the website, you should be able to find both. Okay.